So I want you to take a look at the nearest clock. Just the one on your phone screen, or maybe a smartwatch, or I don't know, maybe just the time displayed in the bottom corner of your monitor.
Right.
And I want you to consider the deeply unsettling possibility that this device is actually lying to you. Lying to you about the very foundation of reality.
Which is quite a thought.
Yeah, it's not a mechanical error either. It might be deceiving you into believing in a whole dimension that just doesn't actually exist.
Oh, yeah. I mean, it's a deception so baked into the human experience.
Yeah.
And our language, too. We lack the basic instinct to even question it, I think.
We really do.
Organize our entire existence around a metric that, well, it might be entirely illusory.
Exactly. So today we're deconstructing how we experience reality. We're pulling from this fascinating theoretical framework we found. It's proposed on an independent YouTube channel called the Amar Naik.
Yes.
And this is from an independent researcher.
Yeah.
His name is Mr. Amar Naik. He has a BSc in chemistry, and he's based in Nafali, Sawantwadi. That's in the Sindhudurga district of Maharashtra, India. And this framework he's put together is called the evolution field, or sometimes referred to as Evoltropy Theory.
Evoltropy theory,
Yeah. So our mission today for this deep dive is to explore how stripping away our deepest assumptions, starting with, the existence of time itself, how that leads to a radically different architecture for space, time, and gravity.
And before we go any further into the weeds here,
Right.
we really need to clearly establish what we are analyzing today.
Oh, absolutely.
The creator of this framework, Mr. Naik, is very explicit, and we will mirror that transparency for sure. We are looking at a theoretical hypothesis here.
Right. This isn't a textbook.
Exactly. This is not established peer-reviewed canon in a university physics textbook.
Right.
It is a thought experiment. But it's one that has been rigorously expanded into a full cosmological model.
Yeah.
So we aren't taking sides or endorsing it as the absolute truth. We're impartially exploring the source material because, it's a masterclass in the origins of scientific inquiry.
It really is.
Which usually starts when someone decides to just poke at a foundational wall to see if it's, load-bearing or just painted cardboard.
Just to see what happens. I love that. And the foundational wall here is a question that sounds almost dangerously naive.
Very much so.
It's just, what is time?
Right.
We all assume we know. We complain about not having enough of it.
Constantly.
We watch ourselves age. We track it every day. But when you ask whether time exists as a physical, independent entity, the standard models of physics actually start getting very murky.
You do. They really do.
So to find an answer, this researcher started by looking at the very instruments we built to track it.
Clocks.
Clocks, yes.
Because the instrument often dictates the measurement. Think about it. We use grandfather clocks with swinging pendulums. We have quartz watches that count the microscopic vibrations of a crystal. And then we have atomic clocks.
Which are insanely precise.
Right. Atomic clocks measuring electron transitions inside atoms. But if you think about it, these mechanisms have absolutely nothing in common mechanically.
A pendulum and an atom are worlds apart.
Exactly. Their only shared characteristic is that they measure the progress of a physical process.
Okay.
It's a mass moving or a crystal vibrating or an electron jumping from one state to another.
All right, so, let's unpack this. Because I was trying to visualize this when I first read the source material. And I realized I've always thought of clocks like rain buckets.
Rain buckets, okay?
Yeah, like a bucket sits outside and it physically catches the rain, right? It collects a tangible thing that is falling into it.
A physical substance, yeah.
But a clock isn't catching time particles. It's just a machine spinning its own gears.
That's a perfect analogy.
Yeah.
Because a clock is only comparing the rate of its own internal physical evolution against the evolution of the rest of the universe.
Oh, wow.
Yeah, it just measures how fast its own state changes relative to, say, the Earth rotating on its axis. There is no background river of time flowing through the gears.
A river of time. That's how we always picture it.
We do. But the source proposes a massive thought experiment to really drive this home. It's called the frozen universe.
The frozen universe. Okay.
Imagine a theoretical universe where absolutely all physical processes just stop.
There's trees.
Exactly. Zero atomic vibration, no particles interacting with each other, no photons moving. Total stasis.
Like pushing pause on a movie?
Right. If you were observing that frozen universe, you would have absolutely no experiment capable of detecting the passage of time.
Because nothing is moving to measure it against.
Yes. If nothing changes state, you have no baseline. And in physics, if a phenomenon cannot be detected or measured or interacted with by any conceivable experiment, well, its existence is highly suspect.
It might just not be there.
Right. And this is the inflection point where the Evoltropy theory hypothesizes that time is not fundamental at all.
Okay, but I'm going to play devil's advocate here for a second.
Please do.
Because things do happen in our universe. I mean, my coffee gets cold, stars explode, people get older. If time isn't driving those events, what is driving them?
Well, the hypothesis states that the physical events themselves are driving the universe. Time is completely emergent.
Emergent, so it comes out of something else.
Yes, it is an illusion generated by the reality of matter and energy constantly interacting. They're constantly updating their states.
I see.
We just use the word time as a human shorthand. It's a convenient way to describe the rate at which physical processes evolve. The universe doesn't evolve because time passes. Our perception of time passes because the physical universe is evolving.
Oh man, we just completely hollowed out the clock.
We did.
Time is basically just a shadow cast by physical change.
That's a great way to phrase it.
But we can't really stop there, can we? Because you can't dismantle time without inevitably crashing into space.
General relativity.
Right, general relativity intertwined space and time a century ago into space-time. So if time is an emergent illusion, well, space might not be this pristine fundamental void we think it is either.
And what's fascinating here is if you look at the inconsistency in how we view the universe normally. Think about it. We know matter is granular.
Right, atoms, quarks.
Yes. And we know energy is quantized. It comes in discrete little packets.
Photons.
Exactly. Everything physical is built out of microscopic, discrete building blocks. Yet for some reason, we cling to this idea that the space containing all of this matter and energy is a perfectly continuous, perfectly smooth expanse.
Just a big, empty, smooth box.
Right. But the Evoltropy hypothesis asks a really brutal question. Why should the vacuum of space be the sole exception to the granular nature of reality?
Oh, that's a good point. Why would space be the only thing that isn't made of smaller parts? So if space isn't a smooth, empty box, what are we talking about here? Are we suggesting the universe is pixelated at the deepest level, like a video game?
The researcher proposes exactly that. He says the vacuum is filled with a fundamental physical fabric, or what he calls an evolution lattice.
An evolution lattice.
Yet not a material you can touch, obviously.
Yeah.
Of an omnipresent microscopic structure. It's the underlying architecture of reality.
So the source actually mentions a conceptual trap here that I think is really easy to fall into. When you hear fabric or lattice,
Oh, the fish and water analogy.
yeah, exactly. They initially visualized this fabric like an ocean. And matter, like an electron or a planet, was just like a fish swimming through that ocean. But they explicitly state in the source that separating the object from the environment is the wrong way to look at it.
It is. Because it creates a false duality. The fish and the water are two separate entities in that scenario, right? One navigates the other. But in the evolution field framework, that separation just doesn't exist.
Okay, let me see if I can translate this for our listeners, because it took me a minute. It is not a fish in water. It's more like a stadium wave at a sports game.
Okay, yeah.
When you watch a stadium wave, you see this massive, distinct structure moving at, I don't know, 30 miles an hour around the arena. It looks like a solid physical object.
But nothing physical is actually moving horizontally.
Exactly. The spectators are simply standing up and sitting down in their assigned seats.
That is a brilliant way to picture it. The fans are the fabric, the evolution lattice.
The fans are the lattice.
Yes, and matter. The atoms making up you and me and the microphone in front of us. That matter isn't an independent object moving through a medium. Matter is an excitation of the fabric itself.
Of excitation.
It is a localized state change in this underlying structure. And just like the stadium wave is an excitation of the crowd.
Wow.
So without the fabric, matter literally cannot exist. Because matter is the fabric doing something specific in that exact location.
So matter is just an event happening in the lattice. That is wild.
It completely reframes reality. The particles are just expressions of the microscopic structure. And if matter is just the fabric updating its state, the fan standing up and sitting down, there are physical limits to how fast that can happen. Which provides a radical new interpretation of the universal speed limit, the speed of light.
Right, because the fabric has to continuously update its physical state to create reality, and it does this through local interactions. I mean, the updates can't just happen instantaneously everywhere all at once.
No, they propagate from one region to the next. If the universe updates locally, those updates happen cell by neighboring cell in the lattice.
Right, going back to the stadium wave, the person in seat 10 doesn't stand up until they physically see the person in seat 9 stand up. There is an inherent processing delay.
Exactly, there's a processing delay. This implies the fabric must be granular. It consists of extremely small fundamental cells or nodes. The information describing the physical universe, whether it's an excitation of photon, a mass, it propagates from one node to the next.
Node by node.
So the speed of light is no longer this arbitrary property of a photon navigating a continuous empty void. It is literally the maximum rate at which the fundamental fabric can update its physical state locally.
It's the refresh rate of reality.
The refresh rate, yes.
The processing speed of the universe's cellular automata.
The speed limit belongs to the fabric itself. Light and electromagnetic waves are simply phenomena that are propagating at the absolute maximum allowed refresh rate of these microscopic cells.
That makes so much sense when you frame it like that. The speed limit isn't about the car, it's about the road.
Precisely.
But I need to push back hard on the cellular idea for a second.
Go for it.
Let's look at the macro scale of cosmology. We know the universe is expanding. We observe galaxies accelerating away from each other all the time.
Right, cosmic expansion.
Yeah, so if space is made of a fixed grid of these tiny discrete cells or nodes, how does expansion work? Do the individual cells stretch out like rubber bands?
That's the logical question.
Because if they stretch, wouldn't the quote-unquote resolution of the universe distort over time? I mean, the cells would get thinner or weaker the further they stretch, right?
Well, the source anticipates this exact mechanical problem. And the answer is no. The expansion of the universe in this theory does not involve the individual microscopic cells stretching or deforming at all.
Okay, then how does the distance between two galaxies actually increase if the cells aren't stretching?
The fabric grows through the appearance of new cells.
Wait, new cells just pop into existence in the interstitial spaces? I'm struggling with that. Doesn't that violate fundamental conservation laws? Like, where is the energy or the information for these brand new spatial cells coming from?
It's a fair point. But within the context of this specific hypothesis, we have to rethink what a cell or a node actually is. It isn't a particle of matter containing rest mass energy.
Okay.
It is a unit of the spatial architecture itself. The fundamental building blocks retain their exact microscopic size and properties. So the expansion of the universe is an increase in the quantity of these cells, not a change in their physical dimensions.
Okay, I think I see. So if 2 points are separated by 1 billion cells today, tomorrow, they might be separated by 1,010,000,000 cells.
Exactly. The underlying resolution of the universe remains perfectly consistent.
The pixels on the screen don't get bigger. The universe just adds more pixels to the monitor.
That is exactly it. That mechanism allows the fabric to expand without losing its fundamental microscopic properties.
Okay, let's take a breath and lock in what we have so far, because this is deep.
It is a lot.
We've thrown out fundamental time and replaced it with physical processes evolving.
Chap.
We've thrown out continuous empty space and replaced it with a granular cellular fabric, an evolution lattice that updates its state at a maximum speed, which is the speed of light.
Right.
But there is a massive elephant-sized hole in this cosmological model right now.
I know where you're going with this.
How does a cellular fabric explain gravity?
Yes.
Because general relativity relies on the continuous fabric of space-time curving under the influence of mass. The bowling ball and the trampoline analogy.
The classic analogy.
Yeah, but if we discard a continuous space-time manifold entirely, we need a completely different mechanism to explain why objects fall toward each other.
And to get there, we have to pull together the two core concepts we just discussed. First, things change. The universe is constantly updating its state. Second, these updates happen cell by cell or node by node. The author, Mr. Naik, posits that this physical evolution is the primary reality. Everything in nature evolves. Stars, galaxies, atoms. And this leads to the defining framework, the evolution field itself.
Here's where it gets really interesting, because this totally flips our standard understanding of cause and effect right on its head.
It really does.
Einstein proposed that massive objects curve space-time. And as a result of that curvature, clocks run slower in deep gravity wells.
Gravitational time dilation.
Yeah, but this Evoltropy hypothesis states that gravity doesn't slow down time. Gravity is the slowing of the local rate of physical evolution.
Let's really dig into the mechanics of that.
Yeah.
Because it's a huge paradigm shift.
Yeah, please.
You're basically saying the refresh rate of the universe isn't uniform everywhere.
Right.
Every single location, every node in the universe possesses a specific local evolution rate. And the fundamental rule of the evolution field is based on energy density.
Energy density.
Okay.
Yes.
Regions with high energy density, say a star or a planet or a black hole. These dense matter energy nodes evolve more slowly. Their local refresh rate drops. It's a reduction in local physical evolution.
So a lot of matter means a slower refresh rate.
Exactly. Conversely, regions with lower energy density, like the deep void of interstellar space,
Yeah.
they evolve more rapidly.
So if I take a highly precise atomic clock and place it on the surface of Jupiter, it ticks slower than a clock floating out in deep space. Standard physics says this is gravitational time dilation. The time dimension is being stretched by mass.
Right.
But this hypothesis argues that the high energy density of Jupiter is literally bogging down the fundamental update rate of the spatial cells in that specific region.
You've got it. The physical processes themselves are genuinely running slower. The electron transitions inside that atomic clock actually take longer to happen because the fabric supporting those excitations, the evolution lattice, is updating at a slower rate.
That's incredible.
The observable effect is completely identical to what we measure in our GPS satellites today.
Because they have to correct for that time dilation, right?
Exactly. But the underlying physical interpretation in Evoltropy completely removes abstract mathematical geometry and replaces it with tangible physical update rates.
Okay, I understand how a massive planet acts like a localized lag spike in the universe's processing speed.
A lag spike, yeah.
But how does a slower refresh rate create the physical pull of gravity? I mean, how does a lag spike pull an apple from a tree?
This is where Mr. Naik introduces the concept of evolution potential and evolution current.
Okay, evolution potential and current. Let's break that down.
Think about the asymmetry of the fabric updating cell by cell across a physical object. Imagine a macroscopic object like an asteroid, and it's sitting in an evolution gradient.
A gradient meaning the refresh rate is changing across the space it occupies.
Exactly. So one side of this asteroid is facing a massive planet where the evolution rate is significantly slower because of the high energy density.
Right.
But the other side of the asteroid is facing out toward deep space, where the evolution rate is much faster.
Oh, I see. So the asteroid is literally straddling two different refresh rates.
Yes. This reduction in local physical evolution near the planet generates what he calls an evolution potential, because there's a difference in the evolution rate between the two sides.
Like a voltage potential in a battery.
Very similar conceptually. And nature abhors an imbalance. So this potential difference starts an evolution current.
An evolution current.
Which is basically a causal signal flowing through the lattice towards the matter energy-dense nodes from the faster evolving nodes.
Okay, let me make sure I'm following. The fundamental updates across the physical structure of that asteroid are not happening symmetrically anymore.
Right.
The side facing deep space, the faster evolving region, is updating its physical state quicker than the side facing the planet, the slower evolving region.
You have it exactly. This fundamental imbalance in the physical update rate across the object's own structure manifests as a directional pull. The object essentially falls along this evolution current towards the bigger mass.
It's like a vehicle with its right tires on perfectly smooth pavement and its left tires in thick mud.
I like that.
The tires on the pavement are spinning faster, they're transferring more energy, and so the whole vehicle violently pulls to the left toward the slower, muddy side.
Yes. The asymmetry in the update rate causes an acceleration toward the region of slower evolution. The massive planet causes a local reduction in the evolution rate of the fabric. And any nearby excitation, any nearby matter, experiences this asymmetric update that pulls it toward the slower region.
That is just staggering.
And that observable phenomenon, that falling along the evolution current, that is what we call gravity. Gravity is just the inevitable physical consequence of a mismatched refresh rate.
I mean, it removes the need for multidimensional mathematical geometry folding in on itself completely.
It does.
It takes one of the most complex, mind-bending phenomena in astrophysics and boils it down to the local interaction of discrete cells updating their state at different speeds. Space emerges from the microscopic fabric. Time emerges from the physical evolution of that fabric. Gravity emerges from differences in local evolution rates. It's an incredibly unified theoretical mechanism.
And it doesn't just stop at traditional gravity either. Mr. Naik applies this evolution field concept to artificial gravity as well.
Oh, really? Like in an accelerating rocket ship?
Exactly. According to standard physics, if you are in a rocket accelerating through deep space at 9.8 meters per second squared, it feels exactly like standing on Earth.
Right, the equivalence principle.
Right. In the Evoltropy theory, when an object like a rocket moves through this evolution lattice, an acceleration forces a relative evolution current to start moving in the opposite direction through the object.
Yeah.
This results in a slower evolution rate for the accelerating object.
Hmm.
The acceleration literally causes an accelerated evolution current, which produces the exact same asymmetric update effect.
So it produces artificial gravity.
Exactly. It's the same fundamental mechanism, just
Yeah.
induced by motion through the lattice rather than proximity to a dense mass.
That is so elegant. But wait, if gravity is just a slowing down of the evolution rate, what happens at the extreme end of things? Like inside a black hole?
Oh, singularities.
Yeah. Standard models kind of break down at a singularity, right? The math just goes to infinity and we throw our hands up.
Yes, standard relativity predicts infinite density and infinite curvature at a singularity. But the Evoltropy theory has a very specific stance on this, which I find fascinating.
What does it say?
It claims to actually disprove the existence of a singularity entirely.
Wait, really? How?
Well, it comes back to the core premise of existence in this framework. The rate of evolution must be non-zero.
Non-zero, meaning it can never completely stop.
Right, because if the evolution rate hit zero, there would be no physical updates. The fabric would cease to express matter or energy. There would be no existence.
Right, the frozen universe thought experiment from earlier, it wouldn't exist in any measurable way.
Exactly. So because the rate of evolution cannot be zero, the neighboring node, evolution potential difference, is prohibited from ever being infinite.
Ah, because if it were infinite, it would imply a full stop in evolution at the center.
Right. The theory sets a hard physical limit. The evolution rate can slow down immensely in a supermassive black hole, causing extreme gravity. But it can never reach an infinite differential. Therefore, singularities as infinitely dense points where physics breaks down cannot exist in the evolution field model.
It just prevents the math from breaking by applying a physical limitation?
Yes.
That is wild. I mean, if this framework explains space-time gravity, artificial gravity, and solves the singularity problem, could this be, the source must hint at this.
The theory of everything.
Yeah, could this be a theory of everything?
Well, the author definitely posits that the Evoltropy theory could be a strong candidate for a theory of everything. By reducing all these complex phenomena to the fundamental evolution rate of a physical lattice, it bridges the gap between quantum mechanics, which deals with discrete granular things, and general relativity, which deals with gravity.
Because it makes gravity a granular, discrete process, too.
Precisely. It unites them under one mechanism, the evolution field.
It's an incredibly unified theoretical mechanism. It really demonstrates the power of just discarding assumptions and starting fresh.
It does. But we must return to the author's own grounded conclusion and be responsible here.
Right, of course.
This framework, while logically elegant, requires rigorous mathematical formalization. It needs to make specific, testable predictions that diverge from standard relativity. And those predictions must survive actual experimental testing.
It has to survive the brutal gauntlet of the scientific method.
Exactly. It has to be proven. But the immense value of exploring the evolution field isn't necessarily about proving it flawless today. It's about recognizing how theoretical physics advances.
Yeah.
You don't find a new paradigm by adding another layer of paint to the same cardboard wall.
Yeah.
You have to be willing to ask questions that make the establishment uncomfortable.
Like asking if time even exists.
Exactly.
We've spent this entire deep dive deconstructing clocks and time. And if we accept the logic of this cellular updating fabric, it leads to a genuinely haunting conclusion about our own existence.
It really does. Let's trace that out for the listeners, because if time isn't a fundamental dimension we are traveling through.
Right. If time isn't a road we're driving down, then tomorrow literally doesn't exist anywhere in the universe.
It isn't a destination waiting for us to arrive.
No. And yesterday is entirely gone. It is simply overwritten data in the cellular fabric.
Just old states of the evolution lattice that have been updated.
Right. So if reality is nothing more than the universe constantly updating its physical state locally, cell by cell right now, we are essentially trapped.
Trapped in what way?
We aren't moving through time. We are just living in a perpetual, endlessly updating, inescapable present.
A localized wave of physical evolution constantly overriding itself. Just the fans in the stadium standing up and sitting down right now.
Just right now, over and over. It's beautiful and terrifying all at once.
Is a profound way to look at reality.
So the next time you look at the clock on your wall or your phone, just realize it might just be spinning its gears trying to convince you of a dimension you can never actually touch. Keep questioning the reality around you. Thank you so much for taking this deep dive with us today.